Our greatest achievements in aviation led us to space travel. We take a look at two space explorations that had the entire world's attention. One aviation company has on two occasions gambled its entire net worth to build aircraft that if they failed to gain sales would have sunk the company. Both gambles paid off in a big way and gave the company two of the most successful commercial aviation aircraft built today. We stay with large aircraft and trace the history of the B-24 Liberator, which was produced in greater quantities than any other American bomber. It also flew in more theatres of war and was used by more countries than any other four-engine bomber in history. April 11, 1970 was launch day for the Apollo 13 mission. James Lovell, commander, Fred Hayes, lunar module pilot, and John Swigert, command module pilot, were poised to further man's exploration of the moon. The mission demonstrates the bravery of the aerospace pioneers. With all systems go, the Apollo 13 project began its climb into space and entered Earth orbit to dock with the lunar landing module called Aquarius. After the docking, the two coupled spacecraft began their journey towards the moon. During the first 2 days, the crew ran into a couple of minor surprises. But at 55 hours and 55 minutes, it all started to go terribly wrong. Oxygen tank number 2 blew up, causing the number 1 tank to fail too. Jack Swigert radioed, "Houston, we've had a problem here."
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Go, guys.
Indeed, the crew did have a problem. The command module was dead. The Apollo 13 command module's normal supply of electricity, light and water was lost, and they were about 200,000 miles from Earth and heading further away by the second. It was decided that the only option was to use as many of the lunar module's appliances as possible. In essence, the lunar module became a lifeboat. Without it, the 3 astronauts would have died. The first concern was to determine if there was enough consumables to get home. The lunar module was built for only a 45-hour lifespan, and this needed to be stretched to 90 hours. Ground controllers carefully worked out a procedure where the command module's batteries were charged with the lunar module power. Removal of carbon dioxide was also a concern. A warning light showed that the CO2 had built up to a dangerous level. Mission Control devised a way to attach the command module's canisters to the lunar module system by using plastic bags, cardboard and tape, all materials carried on board. Ground controllers in Houston faced numerous formidable tasks, but they all added up to, how do we get them back? Completely new procedures had to be written to determine how, when and at what altitude to burn the lunar module descent engine to provide a quick and reliable return home. At this point, Apollo 13 was still on its way to the moon, and for any chance of success, it had to round the moon before it could return home. Ground control computed a 35-second burn and fired it up 5 hours after the explosion. As they approached the moon, another burn was completed, this time a 5-minute-long burn to speed up the return home. Now the craft was at least heading in the right direction, towards Earth. More problems were overcome on the way home, but the big moment was when the command module had to be powered up for re-entry. It was full of condensation, and electrical problems were a real concern. However, everything went as planned, and hopes were now high. 4 hours before landing, the crew shed the service module. It was in this module that the explosion took place, and for the first time, the astronauts could see the near-fatal damage that had crippled their command module. The next stage was to jettison the lunar module Aquarius, which had been their lifeboat and saviour. Then began the re-entry and the crew of Apollo 13 splashed down gently in the Pacific Ocean near Samoa. It was an epic space odyssey, followed by much of the Earth's population, and was later turned into a Hollywood blockbuster which was directed by Ron Howard and starred Tom Hanks. Howard remarked that the event was accurately portrayed and there was no need to add drama to the story, as it had all the elements of an epic movie. From those early fragile days to today, not much has changed. Each mission is still perilous. The first launch of the Space Shuttle occurred on April 12, 1981, when Columbia, with 2 crew members, Commander John Young and pilot Robert Crippen, lifted off from the Kennedy Space Center. Photographers, film and television crew and journalists swarmed to witness this historic event. About 600,000 spectators from both the States and overseas flocked to the coastal area to watch the liftoff. If it was successful, the shuttle project would be the backbone of the USA space program and bring forward projects such as the International Space Station. It was exactly 7 a.m. Eastern Standard Time, and the liftoff would mark another great milestone in space research and technology. The world held its breath when the shuttle rose on its column of exhaust. The solid rocket boosters contain the solid fuel that provide about 71% of the vehicle's liftoff thrust. They were jettisoned 2 minutes after launch at a height of 36 nautical miles. They deployed parachutes and landed in the ocean to be recovered. Next, Columbia was prepared for MECO, or main engine cutoff. At this point, Columbia was in space and travelling at over 18,000 miles per hour. The external tank, which holds 500,000 gallons of liquid hydrogen and liquid oxygen, was released 8.5 minutes after launch at an altitude of 60 nautical miles. Once in orbit, the machine and the crew were put to the test. First test, open the payload doors. A space radiator cooling system is exposed when the doors are open, and this provides the required cooling of the shuttle's electronics. A following test was conducted to check the flight control systems and control surfaces. The shuttle was one of the earliest aircraft to use a computerized fly-by-wire digital flight control system. While the astronauts were completing their objectives, NASA's California Dry Lakes were becoming a hive of activity as nearly 500,000 visitors rumbled into the base to view the spectacular scene of the first ever reusable winged spacecraft glide to touchdown. Back in space, the crew of Columbia prepared for re-entry. The vehicle began re-entry by firing the engines in the opposite direction to the orbital motion for about 3 minutes. This firing was done roughly halfway around the globe from the landing site. The shuttle did a number of arcs and altitude maneuvers to wash off its Mach 26 velocity. Columbia was first sighted by long-range cameras at about 100,000 feet over Anderson Peak in California. The shuttle was decelerated from 26 times the speed of sound to 216 miles per hour. While it completed 2 roll reversals to wash off speed, the shuttle's exterior was subjected to 2,500 degrees Fahrenheit. No test of this stress could be simulated on Earth, and the astronauts were relying on the accuracy of NASA's engineering calculations of this critical phase of the mission. Although the mission was highly successful, a worrying event did occur. While in space, the crew noticed some missing tiles and damage on an engine pod. Also, a little publicised detail about the first shuttle mission was that hot gas entered a wheel well on re-entry, which buckled the right main landing gear on touchdown. Were these the signs of things to come? 2 shuttles have been lost, and their loss reminds us that space travel is still perilous. Yet our human sense of discovery drives us on to explore the unexplored. The first shuttle flight is testimony to this. One company has on a number of occasions bet more than its entire net worth. This company's gamble paid off, and it went on to become an aviation giant. The company was Boeing. In 1952, the company developed a prototype transport plane. The prototype was to become one of the greatest planes of the century, the Boeing 707. William E. Boeing was the company founder and owner. As the company grew, he remained as the president and chairman of the board from 1916 to 1934. Under his guidance, a garage airplane manufacturing business went on to become a conglomerate of air and space-related industries. Boeing sold his interest in the Boeing Airplane Company. Boeing died in 1956. Although Boeing was well ahead technology-wise, their competitors were gaining ground on the famous 707, with planes like the DC-8 and Convair 880. Boeing decided to raise the stakes, and again took a massive risk with the expenditure of $100 million to build even better aircraft. To increase its market share, Boeing decided that customer service was an important issue. Boeing customised the 707 for different clients. They made special long-range models for Qantas Airways of Australia, and they installed larger engines for Braniff's high-altitude South American routes. The cost of customising was high, and every version of the 707 was a financial risk. Again, for Boeing, the risks paid dividends, as sales of the 707 outstripped the DC-8. The 707 entered commercial service in 1958, when Pan Am flew it from New York to Paris in 8 hours and 41 minutes, twice as fast as any propeller plane of its day. The 707 passed a remarkable test. An underwater tank held an entire fuselage, and pressure was exerted on the plane, which was calculated to be the equivalent of 40 years of flying, or 50,000 flight cycles. The plane was intentionally damaged in certain areas to see how long such damage could sustain long-term flight. Amongst the final tests of the 707 was the placing of barrels of water in the plane to simulate the weight of 180 passengers, or 45,000 pounds of payload. Another 9 tons was added just to see if the plane could sustain such an overload. The total weight of the plane was 360,000 pounds. The ground engineers recorded all the vital statistics of the tests, including the performance of individual components and flight characteristics. Over 35 days of flight tests, the pilots flew the plane from very low levels to very high altitudes at speeds ranging from near stall to over 700 miles per hour. The plane and test results were handed to the FAA for their testing and certification. The FAA certified the plane. The biggest compliment to Boeing regarding both the safety of the plane and its capabilities occurred in December 1959, when an Air Force C-17A landed in Rome. The plane had President Eisenhower on board, and he was on a mission called Monsoon. The President was going to visit 11 countries in 19 days. Such a journey on the best plane previous to the 707 would have taken at least a month. This was a clear sign to the world that the jet age was here. In India, Eisenhower visited the Taj Mahal with President Nehru. When he arrived in Athens via Tehran, he had covered the entire rule of Alexander the Great in just 1 day's travel. He went on through France, Spain and Morocco before returning to the United States. The trip was an absolute success. Huge crowds met him wherever he went, and they also saw the future of flight in the Boeing 707. Today, with planes derived from the 707's remarkable achievements, many people have the opportunity to follow in President Eisenhower's footsteps and to travel to places that once seemed so far away. Boeing didn't stop there. They took another gamble, and like before, if it failed, the company would be lost. On July 25, 1966, Boeing took the first physical step of building the world's largest commercial aircraft. But before the construction of the plane started, they had to build the world's largest factory. More than 2,800 men were employed to construct the factory that had a capacity to build several jumbos at a time. Prior to starting the building, much research and development had to be done to confirm exactly what Boeing wanted to create. Thousands of hours were spent on wind tunnel tests and on paper designs to reduce drag as much as possible. Drag determines the plane's fuel usage, and this equates to money. For the 747 to be a success, it had to be economical to operate. A full-scale mock-up of the 747 was built to test every part and component of the plane. Basically, that first 747 was nothing more than an engineering tool. Components were arriving from contract companies both nationally and internationally. When full production began, all these 4.5 million parts had to arrive on time every time. The logistics were as huge as the plane itself. This is the first jumbo coming together. This is the theory being tested in practice, and a plane becoming a reality. The tolerance of the engineering process had never before been so stringent in aircraft manufacture. Many substantial obstacles had to be overcome to reach this point, and the tension was heavy, as this was the make or break point of the project. It was not only the large parts of the jigsaw that had to fit, it was the millions of small pieces that also had to fit and operate perfectly. Over 75,000 engineering drawings were used, and each assembly instruction had to be followed to the letter. To get the plane together for the big presentation day was a colossal job. The first plane was rolled out on September 30, 1968. Development costs at that time were said to exceed $1 billion. But that didn't include the cost of the world's largest factory. The first two operational planes were created just to be destroyed in one of the world's most expensive destructive testing exercises. This is a wing flying for the equivalent of 30 years. This is a wing breaking after being pushed upwards by 29 feet. One test saw the tail of the plane dragged along the runway until the plane actually reached its minimum unstuck speed. Undoubtedly, the tail wouldn't hit the ground in commercial use. The rejected takeoff test is another interesting experience for the test pilot. The brakes are locked up and the plane is given full throttle down the runway. First the tyres blow, then the undercarriage gives way, finally the fire starts. Anti-lock brakes, now common on cars, have been used on the jumbo from the very beginning. Another test is to land the plane with a number of wheels locked up. This tested the tyres and what would happen in the event of tyre failure. It also demonstrated what would happen if a braking malfunction occurred. It wasn't all smooth flying for Boeing. There were some problems. The plane's huge size was one. The first jumbo was overweight and would not be of operational value. Regardless of the problems, Boeing worked through them with the same dedication that they had when building the plane. What Boeing had built was an aviation milestone and will probably go down in history as the greatest commercial aircraft of the last century. The B-24 Liberator sits in the shadow of the most famous bomber, the B-17 Flying Fortress. However, in the beginning of the war, it was the most influential bomber and was manufactured in great numbers. A total of 19,256 planes in several versions were produced by Consolidated Vultee, Ford Motor Company, Douglas Aircraft and North American Aircraft between the years of 1939 and 1945. The total number, including the variants, is more than any other US bomber of any era. The success and strength of the B-24 Liberator is due to a wing design sold to Consolidated in 1937 by David R. Davis, who was a near-destitute inventor. Reuben H. Fleet, the president of Consolidated, was convinced through wind tunnel tests that this slender wing with sharp camber would provide greater lift. Not only was the B-24 Liberator produced in greater quantities than any other American bomber, it also flew in more theatres of war by the air forces of more countries than any other four-engine bomber. Today, there are only 2 flight-worthy B-24s in existence, and its history and role in World War II is only dimly recalled by those who flew them. A fully armed and combat-ready B-24 carried a crew of 10 men. Its gross weight when loaded was greater than 60,000 pounds. In its most common form, it had 4 movable turrets, each with 2 50 caliber machine guns, and 2 individual 50s in the waist, making a total of 10. It was powered by 4 1200 horsepower engines and carried 2,750 gallons of fuel. Many B-24 missions were round trips of 1,500 miles, and some extended ranges were closer to 2,000 miles. The planes were not pressurised or heated. Crewmen wore oxygen masks on high altitude missions and were exposed to temperatures that reached minus 30 degrees Fahrenheit and below. It operated against heavily defended targets in the European theatre and was flown from 18,000 to 28,000 feet, although on many missions, particularly in the Pacific, much lower altitudes were experienced. The most common bomb load was 10 500-pound bombs, or 5 1,000-pounders. All in all, the Liberator was a plane that excelled in every area. But its humble beginnings basically originated in Consolidated's experience in the PBY series of flying boats.